Hello, everyone. Welcome to this new episode of Code and Deploy. In this day, welcome everyone. So it's the last episode was 1 month ago. So we are very happy to have this series. So for those of you that are new to this kind of series, this is a coding session, right? So we used to work with open source members from the community or people that is contributing to projects or creating projects or doing things in AI, and we invite them to code with us and to show the great work that they are doing. And talking about that, first of all, as usual, I love to know from where you are watching us. So let us know in the chats from where you are watching us. And talking about this coding session will be again as AI agents with a very fun use case that I will let the guest to introduce the use case. In that case, we'll be talking about a very fun use case, by the way, right? And we have a great guest, to be honest. She's working with an AutoGPT. She's an AI engineer, and she's been working for the last 6 years. I'll let her to introduce herself. But actually, something that I really love that is that she wrote a book. So she has a book. And every time we try to learn from something when we are working with AI, we go to the books, right? So we try to read from people that had the experience. And this is what a person that we have here in our show today. So his name is her name is Aarushi, and so Aarushi, welcome to the show. How are you?
Thanks. Yeah, I'm good. Thanks. Thanks for having me. I'm very excited about this live coding.
No, we are very happy to have you. So to be honest, I didn't have the time to write your book. I would love to have the time to write to read it, of course. But let us know first. We know that you are working in AutoGPT as an AI engineer. So let us know what you do, and basically what you're passionate about AI, right?
Yeah, sure. Yeah. So, yeah, at the moment, I am an AI engineer at AutoGPT, and this actually coincides quite nicely with our launch as well for the next generation of AutoGPT, which is what I will be coding on in this episode as well. And yeah, I've been doing AI engineering at AutoGPT and previously at Bumble as a principal engineer, and I've done the traditional machine learning at different companies as well. Yeah, and so for the reason for why I'm excited and passionate about AI, for me it seems like what the equivalent of the internet must have been like for the 90s, right? So it was like a whole new thing, and if you got on board, you got on board and you were successful, hopefully, and built something cool. And I think that's exactly what AI is going to be like. And in 20 years, we're probably going to look back and it'll be the equivalent of those like 90s and early 2000s websites, like those really cringy ones with like the music and the glittery icons and that kind of thing. Yeah, so I'm just excited to be part of that start,
Amazing.
basically.
Yeah, I totally agree. I totally agree with that. I don't want to spend a lot of time on that. I know it's a coding session, so we should dive into the code and we should go there. But could you tell us about your book, about just to let the viewers know what they can learn from your book, right?
Yeah, so my book, it's called Building Generative AI Powered Apps for Developers. And so the goal of the book when I wrote it was to really focus it on engineers as opposed to data scientists or machine learning engineers who are like already very much experts in building models. But for the people who just want to be able to take models, either fine tune them, do some kind of RAG systems, agent based systems, and put up an application into production, whether it's a quick proof of concept or like a heavy production application. And so it starts off quite small. It focuses on things starting with like really basics of like memory management, tool management, then how you string them all together into like an agent system, which is what we'll talk about in this session as well. And then it goes into some of the techniques for fine tuning open source models like Llama.
Oh, amazing, amazing. And if people would like to buy it, I assume that it's on Amazon. It's somewhere, I think.
Yes,
Yeah.
it's on all of them. So
Nice.
Amazon, O'Reilly, if you have a subscription, you can just get it for free off that.
Oh,
Yeah,
that's great. That's great. Yes. I mean,
yes.
we'll put the link on the chat later, of course, when we post the recording. Yeah, but let's start diving on the use case. I didn't want to talk about the use case because I would like you to explain the use case. So first of all, let us know what we'll be doing today in our use case. For those of you, I mean, I had to use headphones just to hear your voice better. So let us know what we'll be coding today.
Sure, yes. So we'll be creating a skincare agent that is able to take your photo from your webcam, have a look at it, and make some suggestions on what you might need for your skin, and then creates a curated list and emails it to you. So while this use case is for skincare, it comes from a place of, in my experience, right, building like with AI, building anything with AI can be more useful when you can work with your internal teams on some kind of use case, which in this case could be like a marketing gimmick for a skincare company. And the goal is to see how somebody who's quite non-technical can work very closely with a technical person. And when you come together, you can create this agent that can live on a website, or it can live within our platform or somewhere else if you want. But it can be very fast, very quick and easy, and really like enable a bit more of
Oh,
collaboration.
that's amazing. That's amazing. I think that will be very, very useful. I think also for me on how to use it. Why not? So yeah, let's go. Let's go. So I will let you to share the screen. Yeah. Now your screen should be showing. Just let us know, the audience, if you are hearing well, if you are seeing everything well. Just let us know in the comments. So Aarushi, stage is yours.
Okay, cool. So let me get to my PyCharm. Okay, cool. So before I get started into this, actually, I think my Docker just crashed. Give me 1 second to actually spin up Docker again.
No problem.
I saw it crash just as you said, take the stage.
That's a live coding
So,
session, so that's the point. Don't worry about it.
okay, cool. All up and running. Um, so So we've basically, as an introduction, it doesn't matter if you're going to build this within our platform or if you're going to use one of the many frameworks that are out there. What we're going to focus on is retrieval augmented generation for skincare. And the reason that we're going to focus on retrieval augmented generation is that it is a great way to prevent hallucination without jumping straight into fine tuning. And it is also, you've heard the phrase like data will be your moat. It's also a great way to start using your very niche and custom data, again, without having to jump straight into fine tuning. While fine tuning can be great, it is time consuming, resource consuming, and can potentially be a barrier to entry as well for a lot of people. So depending on how much time we have, first we'll start with the RAG part of it, and then we can also go into a little bit more of like the embeddings and chunking and all of that. So the basis of our entire platform is based on the concept of blocks. And so, for example, a block can be almost anything. It can be a large language model. In this case, one of the ones that we already have is for literally just generating text. We've got integrations with OpenAI, Anthropic, Grok, as well as Ollama. But then it can also be operations, so like doing math. It can be logic as well, for example, like branching, doing comparisons. It can be an email block if you had your own SMTP server. In this case, we're going to end up just using SendGrid, and we'll build that out as well. So, and the way that you run it, you can run it all through Docker Compose. So let's just let that build. And then we have the front end, which should already be up and running. Yes, so you can kind of see what our system looks like at the moment. So when I mentioned earlier about collaboration, so the point is that you should be able to build blocks or use existing blocks, and then yourself or anyone who maybe is not as much as technical should be able to just use them and write whatever, or use them in any way that they want. So Germany, for example, if I was using it for that for some reason. Right, and then they don't need to have an account. They don't need to worry about configuring anything. No APIs, none of that. Oh, this probably won't run because the system. Oh, it should run actually. Let's see. Okay. Really a live session when it's already crashing.
So basically what you're doing is you have your compose file when you have I imagine all the RAG pipeline, kinda, right? With
Exactly.
everything there, and you're launching all of them to consume them in this. I mean, you start as a service and you consume that as a service, like in the local URL. Yeah.
Yes, so exactly. So it can be a drag and drop, no code system that anyone can then integrate with. And then there's also obviously the code for building the blocks, which anyone can contribute to as well. Yeah, so as you can see, it ran and told me the answer. That's obviously just one very simple, probably not a useful use case, but we'll see the actual uses. I just wanted to show you what the block system kind of looks like here. Okay, cool. So let's actually do some code then. So we go back. What we're going to do is start creating a new block. So we'll start with the actual RAG, like the actual RAG system. So I'm going to just name it RAG pipeline. Cool. And so I will take, as a way to get started, I'm just going to take an existing block and delete the code that I don't need and add the code that I do need. So the crux of everything in this system, it runs within the run function. All right, so when you hit run, this is where majority of your logic will sit. So for now, so let's start renaming some of this stuff. So we don't need any of this. This is all model stuff, which we do not need right now. Okay. Actually, this is probably a bad one to start with because it's got so much code in it already. So I'll delete all of these. Okay, cool. So now we just have the one class and we can name it whatever we want. So I'm going to name it RAG pipeline block, and it inherits from our block class. So when we think about a RAG system, the first thing that you would do for all of your information would be you would integrate, you would take all of your data, and most likely it'll be very unstructured. So you would clean that data. You would create some chunks out of it so that you're not just ingesting entire documents. And then you would create embeddings out of that and then store that in a vector database. So depending on time, we can also go through that, but to be able to get through this, I've already created the embeddings in using Pinecone as the vector database. And basically the embeddings are just a way for the computer to understand, human language, human photos. So it turns your language into numbers. And depending on how close the words are in semantically, these vectors will be stored closer together. So for example, cat and dog might be stored closer together in the database. And then your large language model, when you do querying, you can understand that these two are semantically very close. And that's how querying works within a database, within a vector database as well. So we've got the information within your vector database as a set of embeddings. When I ask a question such as, what should I do for oily skin? My question will also be turned into embedding, so numbers. Then this vector will be compared to the embeddings in the vector database, and the documents that are the closest to my question will be pulled, and you can choose how many you want. We'll take those documents and we'll put them in the context within a prompt of a large language model. So then it's able to craft an answer based on the information that you want to be using. And that's where this thing of minimizing hallucination and using your own data comes into place, because all of a sudden you're kind of narrowing down the information that it's trying to focus from. On top of that, ideally, you have some data that's not available on the internet for the world to train on either, and then you can provide that to your LLM. Okay, cool. So let's get started then with that. So some of the things that you'll need with using Pinecone will be like your index name, where it's going to be stored. So that's going to be a string. I'm just going to pull up the docs as well on my machine. Okay, cool. So schema field, and I give it like a description.
So you are creating, you are editing the block that will be doing the query of the database. Did I get it right?
Okay. Yes, we're creating this one. Okay. And this will be our very first actually RAG block on the system as well. So yeah, nice. So we're going to create that, and then it'll be able to query directly to Pinecone. Nice. Based on some kind of question. And then we'll need a API key as well. Cool. Which will actually be a secret. Secret field, actually not that. Okay, cool. Description, Pinecone API, that's fine. And then the name of what to pull as well. So I'm going to call it literally just the same thing. Okay, cool. And then we'll need a few more things like GenA as well. So with GenA, we're using for a few different things. For creating the embeddings, for scraping the internet if you wanted to, and for chunking as well. But you can use any models or any other services that you want. I just did it with GenA because, like, yeah, why not?
So GenA, cool. GenA as a service. I mean, what?
Yes, so GenA is a service, basically. I can pull it up if anyone's interested. So you can use, they've got a bunch of different APIs right now. So we're using the embeddings to actually create the numbers that I was mentioning before.
Oh, okay.
Reader to scrape the website. And then there's a couple of other ones for chunking as well. I think they have fine tuning as well. I haven't used any of the other ones, but embeddings and Reader is the one I'm using right now.
Okay.
Cool. Yeah. Okay. So the GenA API key. Then we are going to also add the OpenAI. So I'm going to try this with Ollama, but I have been having issues today with Ollama crashing, so I'll have OpenAI just in case, just to see that you can make it work as well. Yeah. But we'll try with Ollama. So block secret, secret field, OpenAI, API key. Okay, cool.
And in those blocks, for instance, if you have anything local, as I said with the embedding, instead of using the GenA or instead of using the OpenAI or whatever, you can refer to any local block, right? Any local LLM that you probably will be using. Okay.
Exactly. So, for example, if you're using Ollama, you can start a REST server, so you can literally just replace using GenA and call your local Ollama instead. Yeah, nice. Exactly. Okay, cool. And so then I'm going to add query. This will be the actual question that you'll be asking, or well, actually the LLM will be asking for it when it goes through and looks at your photo. So let's name this something nicer than that. About a topic. Okay, cool. Namespace. Some of these are very specific to the vector database, which is fine. But we'll just put them all in quickly. Schema field, namespace, description, namespace, top, I'll need the K and the RAG technique. Okay, cool. So top K is the number of documents that you want to return.
Okay.
In this case, we're going to default this to 3. You can change it to a lot more if you want, if you think that will make it better. The more documents you add, you might get more information, but you're also going to use up a lot more tokens. You're also likely that the LLM, when it's using all of the documents in the context, it's not going to remember some of the information from further back. So it's really about fine-tuning how many documents you really need depending on what you are working on or what your domain is. But 3 is a pretty standard number to get started with. To return, and then the RAG technique. This is the one where we'll implement a few different ways of doing this. So as I mentioned, we'll do like a basic one, which is literally just asking an LLM, what should I do for oily skin, and having it query the Pinecone database. And then we'll do some of the more complicated ones, which is chain of thought, hybrid document embeddings, and multi-query. And I'll go through each of them if you want. Yeah. Use, and then we're going to default that to just like basic, we'll call it. I haven't created this yet, but I would like it to be an enum of some kind.
So this is basically how the search is done.
Yes, exactly. Okay. So we'll create this as well. And actually, that doesn't need to be a block. Okay, cool. We had basic, which will literally just be basic. And COG. And we said we would do hide and multi-query. What am I missing here? A second. And multi-query. What's the issue? What doesn't it like? Go target. Oh, oops.
Oh yeah.
Okay, cool. Yeah, so these are the ones that the user will be able to pick from, and they'll become a dropdown. So let's actually go ahead, and we don't need any of this anymore either. Okay, and then what will we do here? Okay, so here we need to actually, for this system, we need to add a generated UID as well. So I'm just gonna go ahead and get like, literally just get a UID somewhere for now. Okay, cool. And then description is fairly obvious what that is. Okay, so block 2, query data from Pinecone. We can probably change this. For now, it's going to be very much tied to Pinecone, but we can change this later on to be a bit more generic and like be able to choose the same way you can choose the prompt technique to be able to choose the vector database that you want to go from.
Okay.
And so the categories here, we have a few different categories as well right now that I will choose will be, I think, like logic probably makes sense here. Input schema will need to be the same name here. Block. Okay, cool. Okay, this test input, which is basically just used in our testing system as well. But for now, I'm going to just remove that so we don't need to spend too much time worrying about that one. Okay, so everything looks okay for now up to there. I'll remove all of this code, and this is where the RAG technique will actually run. So since we have a few different ways that we want to do this, first, okay, so basically first what we're going to do is do the embeddings. So when I said that when you query your database in natural language, it'll convert that also into a vector, into something that can be stored inside of a vector database. This is what that step will do.
Nice.
And we'll use, and yeah, we'll just use GenA for now.
Use the same. Okay.
And then, yeah, exactly. So we'll just use GenA. It's nice and easy. Let me grab what their URL is actually. It's not that. Sometimes AI definitely does hallucinate. Okay, that's their URL. And actually, I'll send the link to the docs as well that I've been using for this. So that's okay. Content type, all that normal kind of stuff. For API, cool. And then the actual data that we want to be sending as well, which will be your input, which is the text. This though, model. So they have a few different models, I think, and I'm gonna pull up which models that they do have. So the model we'll go with will be GenA embeddings v3. It's okay. Cool. Let's do that. What other ones? And they've got, yeah, a bunch of different ones for us to use from. Yeah, but this one should be okay. Or we could also maybe just do, yeah, it's fine. Yeah, okay, cool. So that should be enough. Okay, and then there's nothing all that special about this one. We're just doing a pretty simple request. And then status, it's fine. What do I need? Oh, type that wrong. Okay, cool. So the first thing that will do is whenever you input your text, it's going to call the get embeddings. We haven't implemented writing where that'll actually happen, but we will in a second. So then I guess let's actually do the steps. We'll go step by step. So the first thing is the embeddings that need to be created. Then it needs to be the query to the pinecone. So we'll write that, and then we'll do the different ones as well. So query pinecone. Should be okay. And these are all of the things that we need. Index name, yes, that's fine. And then we need the API key. It's also a string. We needed the namespace, the query Sure. That should be a list, I think. Namespace. Also string technique. That one doesn't need to be the here in this case. It's going to remove that. Okay, cool. And what this will actually return will be a list because it's going to return a few different documents. We're going to do top 3, I think, at the start. Cool. So we're just using the Pinecone SDK for this. Index name, API key. I think that's probably too much. You don't need any of this, I believe, in this case. Just the API key. And then the index will be c.index. And then we use the index name. And then the results, which will come from querying the actual index. Wanted query. And so here we'll tell it the vector that we're going to be using. Vector. Okay, she'll tell us how many to pull out, how many documents to pull out, include metadata. So we're going to store some of the metadata, the chunks that we create as metadata as well, and then the namespace. And in this case, when we do it, we'll just run in the default namespace. Okay, cool. And then return results.matches. Should be results.matches, I'm pretty sure. Yes, okay, that does work. Okay, cool. And then, yeah, so that's all this is doing is you've got the index name, the API key so that Pinecone can actually authenticate. We pull the index that we're using, and then we query it, and we tell it how many documents to take, whether you want to include metadata or not. Metadata can be useful for when you have pulled a bunch of documents and then you want to do some kind of filtering, for example. And yeah, and then the namespace that we have for the Pinecone database, which will just be default. There's nothing that fancy that we need right now.
And the return will be the top 3. Sorry, the return will be the top 3 documents most similar with the initial vector that we are sending.
Yes, with the query that you asked. So if you ask for oily skin, the 3 that are most relevant to oily skin or oil, okay. That kind of thing.
Nice.
Cool. And then we're going to actually, now we'll do the prompt engineering techniques. Mm-hmm. So the first one that I want to do is to generate hypothetical documents. So basically what that will mean is that when you ask a query, it's going to try and create hypothetical documents, and then we're going to embed those. And then based off of those hypothetical documents, so if you asked a question, we'll be like, okay, if you got asked this question, this is what the best documents might look like. All right, create these documents, and then these embeddings, these documents will be embedded, and then we'll search the database for the documents that are the closest to what the LLM has generated as saying like these would be the most useful to be able to answer this question. Okay. And so the reason, sorry.
No. Go ahead. I have a question for later. Okay. Go ahead.
Okay, cool. Yeah, and so the reason that we are going to do this is that is supposed to, in theory, make searching a database more accurate or more useful for the LLM when we're searching based on what the LLM might actually need. And we can actually, we'll be able to, we'll like go through and we'll try each of them out and see which one works best or which one doesn't.
So you have a model after that. So you have a model that is generating these hypothetical questions most similar to your question, right? Or
hypothetical answers most similar. Yes. Okay. So it would be like, okay, yeah, if I had a document like this would help me answer the question of what to do for dry skin.
Okay.
And then those ones will be used. Okay, cool. So, okay, I'm just gonna create this one. So what we need is to generate the actual hypothetical documents. Hypothetical documents. actually self. What do we need? The query, obviously.
I think you have cells
I don't.
twice.
Oh, okay. Thank you. Okay, cool. We don't need namespace, top K, none of that actually. And we need, we'll just need the API key. This is not returning a date. This is returning a string. Okay, cool. So that's the OpenAI API key. Okay, and then I remember this off the top of my head. Is OpenAI that, yeah, great. She'll go through. Okay, cool. And so the model that we will use will be GPT-4o or Mini, whichever one, or Llama or any of the other ones if you're running Ollama or Grok or anything else. So for messages, what we're going to tell it now will be, so we wanted to generate hypothetical documents. So I guess we can just start with something simple and fine tune it if we need to. So this is the role for the system will be, I think it's this one. I might need to pull up what the actual thing is. Hang on 1 second. Okay, yeah. Got it. So yeah, so it goes content is, I'll say like, you are an AI that generates hypothetical documents based on queries user. Okay, cool. And then we need the user role as well. And this is when they'll give the content. And then we'll be using the user's query or the large language model's query. Message containing information about the query, I guess. Okay, so we are passing the query in to the large language model, and we're telling it to create a passage containing information for the following query. And then whatever that response is, we will then use that to compare. Compare it with to what exists within our database and pull the right, ideally the right documents from there. And then I think so. Actually, I think I might just increase this max tokens. It doesn't need to be. Okay, cool. Okay. Cool. So that's the generation step. And then we need the step to actually then query the database, make those hypothetical documents, and so on. So I'm going to call this like high technique. So in this case, we'll need the query. And then we'll need the API keys, API key. Actually, no, we'll need multiple API keys, so we'll just call it dict for now. So we're going to use GenA and Pinecone for this. That'll be a string that it returns. Okay, cool. So first thing we're going to do is we're going to get the hide document, for example. So generate hypothetical document, and what is that takes the query, the API key, which will be, but what we want is the OpenAI one. Cool. Query string. Yeah. Okay. Cool. So then now we have the document. Ideally, we are going to create the embedding then. Again, we've got the function already. Get embedding, and I think it uses text. So this is where we'll pass in the actual doc that we created. A document. API keys, Pinecone API. No, that's not what we want. Need the GenA API. Okay, cool. And then from that, we should have some results, which I think from the Pinecone documentation, pull that up again. Should be so query. Yeah, okay, so query Pinecone, and then index. No, I don't think we have. Yeah, so this is specific to us. So we're using input data rather than input, like specific to our system, index name. Namespace. Dot, and then how many we wanted to pull out. Okay, cool. And then, oh yeah, and obviously we need the Pinecone API. Which is API keys, Pinecone API, and then the hide embedding that we just created as well. Okay, cool. So that should get us all of the results that are closest to that document. We can make it generate more if we wanted as well. We could have put this in a for loop and make it do 3, 4, 5, however many. But for the sake of this, I think 1 is enough to demonstrate what we're trying to do. Cool. So it's got that, and then we are going to actually add that to the context. So I go ahead and go like, I'm going to format this nicely. So join, and then results that we have. So I mentioned we have the metadata as well. So we're going to go ahead and use that. Which is the actual like the language words, like the English words. Yeah, actually this needs to be this as well. Then the results, which is the metadata results text. Cool. For results in results. Cool. And then we can create the prompt with this context. So let's think about a prompt that we would want to use for this. So basically what we're trying to do is that we want to make it only do it from the information that we have. So we definitely want it to only use the context. So let's just start with something simple based on the following information and only the following information.
Okay. Yeah, we need to reinforce it, right?
Yeah. Yes, exactly. Answer the question. And then the query will come in here. Very cool. And then we also still need to put in the actual context. So we'll tell it if this is the context. Context that you have of information, which is context. Cool. Should be enough to get it to answer what we want as a starting point. Cool. So that's our prompt. Cool. And then we can actually call the actual. So we've gotten up to context, prompt, and then let's actually call the API as well, obviously. So what did I have? I'll just copy this. And this needs to be keys OpenAI. Okay. Cool. And then in here, we need to obviously change what we're trying to do here. So here we're no longer doing that you are creating documents. You are now a helpful assistant. Assistant that answers. I'm trying to keep this a little bit more generic, so that it can be used regardless of the information that's being put in. So the niche part of it comes from the context from the database, but the actual prompts can stay relatively generic, so that you can then start to rinse and repeat basically for this. Okay, so questions. You are a helpful assistant that answers questions based on the provided context. Okay, cool. Yeah, and then we're going to change this as well to just give it the prompt. Okay, cool. So that's our prompt, and then we can return response.choices. Okay, cool. So before we do any of the other ones, I'm gonna actually just start writing the run part of it so that we can at least see this this part run essentially. Cool. So here, I'm just gonna go self. So yeah, we'll put in the logic for if we had other stuff, but we don't. So that's where this input data comes from. And then what we're going to do is we're going to set up our API keys. Dict. The input. Input data dot set up an AI key. Secret value. Well, it's not working. Okay, cool. What else? The other ones, Pinecone. And okay, cool. And then we are, I will not do like an if else statement for now. Actually, yes, I will. Which will tag equals this one, basic, because that's the default one. But I haven't implemented that one yet, but that's okay. I'm just going to go ahead and call this hide then. And it's going to go ahead and go response equals self dot, which was the hide technique, right? So use the hide technique. And what we're going to do is input data. That's where your query comes in. And then API keys, which we already have. Once that. And then else. We'll just say it's going to be a problem if anything else is there for now. We can add more later. It'll be like unknown. Our technique. Cool. And then we want to yield. This is what gives us the outputs, which I showed you earlier. So we don't have to have this one, but so that you can see the output later. Okay, cool. So this part of it should be enough. Except yeah, exception. We can have an error message come out as well, so that it's clear what's gone wrong. And I'll just go error during query. ASTR E. Okay, cool. And then we can just yield that as well. And then we can yield like a, I'm sorry. And then yield. Oops. Okay. And we'll just say nothing was used. Okay. So there's only 9 minutes left, but let's try and run this. So we've got this much of this. I think everything is there. So let's rebuild. And then while that's rebuilding, so basically we didn't get to adding the actual email block, like the LLM based email block. But what I wanted to do was have the vision model with a webcam take a photo of yourself. It should be able to then analyze your photo. And I've tried this out with GPT 4.0 a bunch of times, so it does do it. It can kind of roast you a little bit as well. And then based off of that, within our vector database, we have a bunch of information sitting there for like what I decided was the right skincare kind of information, and pulls the information and then is able to answer you. But I don't know if we'll have time for that, but yeah, go ahead.
No, I wanted to ask you. I mean, you mentioned something about that, but I mean, the information. What is information you have in your Pinecone database? It's like, I imagine details about skincare or something like that.
Yeah, I can actually show you what I did for this one actually. So the way that I've done like the first part of RAG, which is the data ingestion part, literally just goes. You can do it in lots of different ways, but for within our platform, we have a few different blocks that I'll show you right now. Chunking and embedding, okay? Plus the pinecone init. Where is it? Init block, and then I have a data ingestion block. Okay. So what will happen is that you would go all of your texts, chunk them first, then you create the embedding. Then we've got the pinecone in it. So this is if you want to create a brand new one. So I will, for example, skincare agent 2. This is my index. And what do I need? Embeddings, chunking, embedding. Yes. Okay, cool. And then what we'll store will be embeddings, as well as the chunks that go here. Right. So I mentioned that we store the actual chunks within the database as well, so that we have the actual real language words sitting there as well when we pull which information. And so if I run this, let me call this agent. Okay, cool. And so I should be able to run this. Oh yeah, and then I've got to put a bunch of URLs in. We can do this in different ways, but for now I'm using Reader to scrape the database, scrape the internet. So I would go like, actually, I think I might have a couple open somewhere. Let's see if I have them. Yes, I do. Okay, cool. So I'm going to take, for example, these kind of bits of information, and you can add them. And we will scrape the information. Let's take a couple more. Let's see what else is there. This one. And I just chose these because they've got skincare routines plus actual information about actual products and brands that I quite like. Cool. And so now, what else? Is there anything missing in this index? No. Cool. So now it should run. So you can see the reader scraping the database, and I'm going to pull up the logs as well. because the output isn't showing right now. So you can see all of that running. So it's created the index here in this block, completed. It's still running on that one. So you can see now it's literally scraped all of this information from all 4 of my websites. It has now created chunks of this
The chunk is
information.
totally random. I mean, or you have a fixed number like 1,000 or, but the number you select is
You
random
can
or not.
no. So we have a default value of
Okay.
1,000. You can
Okay.
change this.
And you are using 1,000.
To what?
Okay.
Yes, I'm using 1,000
Okay.
in this case. And then once the chunks are there, it then creates the embedding. So this is what I mentioned about the embeddings being literally just a list of numbers based on meaning. Yeah, and depends on the model how well the embeddings are created. And then the data ingestion has happened as well. So yes, so let me see if I have an actual, I think I have a query block just to see the query kind of thing. But it has to be a vector as well. Okay, actually, I think I should be able to, what I should be able to do with this one might be, okay, so if we delete all of these, so it's created everything, but if I want to actually test, okay, yeah, let's do this. I haven't tried this, but let's see if it works. We've got what I called it actually, skincare 2, I think. I can check. So I'll call it, should I do about oily skin and redness on my cheeks? Say that. Okay. So this should create the embedding, and that should be enough to do what I'm trying to do here. And let's just do like an output block.
And all these blocks that you're mentioning there are of course are blocks that are already created or it's in the API, I think.
Yeah, so these blocks are
Okay.
created. The one that we were just coding isn't created
Yeah.
yet, obviously, or as in, but anyone can contribute and create blocks and integrations and all of that kind of thing. So let's just see if this is going to do what it. Okay, no, didn't work. Maybe I used the wrong. Don't remember what I called it. Let me check what I called it actually on Pinecone. Just checking. Okay, I did call it skincare agent 2. Maybe that's why. See if that will work. No, that's not going to work. I need to figure out what's wrong with that one. But in theory, it should have, by using this embeddings, be able to query within Pinecone and find the right answer. I could try it actually if you want here within Pinecone and see if that works. So here, I think here is where I would. Not all dimensions are numbers. Interesting. Okay, I don't know what that one is. So maybe I can't filter right now on this one. But yeah, so that's the point, that it should be able to do that. And if we spent a little bit more time on getting that block up and running, but I can definitely record a video of it once it's ready.
Oh, don't worry. That is great. I mean, I'm not too familiar with AutoGPT, but I think that's great. I mean, because it allows you to actually create your pipeline. I think that what we've seen now was great. Like how to create a pipeline. We are always talking about seeing this stuff probably in a Jupyter notebook, right? So we don't actually see it running in a containers or in containers or even in the visual part of AutoGPT. I think it's great too. Yes. So for the audience, just let us know if you have any questions. We'll keep talking for a few minutes. so, so tell me about. I have one question about AutoGPT GPT actually? Is it an open source project, right? So it's using multiple open source components. So if people would like to be
Mhm.
involved, if people would like to, of course, to contribute, how can people do that, right?
Yeah, so everyone is more than welcome to join our
Mm-hmm.
Discord server. We've got our GitHub as well, which is fully open source for everyone to work on. You can create a pull request if you want. I don't know if I can link to the GitHub repository from here or if someone else can. Um, I'll just
Yeah,
send it to you, and if you want to share it with
yeah,
the
yeah.
audience, they
I can
can.
put it in the chat. Let
Um,
me.
okay, cool. Yes, yeah. So basically, Twitter, Discord, and GitHub is our most active platforms, and we have loads of open source tickets open as well. So if anyone wants to jump in, feel free to. Especially with creating blocks, that would be a really fun one for anyone that's just looking to get started. You don't have to be any kind of super duper programming expert or super AI expert. It's just building integrations. Anything that you would think is interesting
Yeah,
for
this is
you.
something that we always mention. All people used to ask us, like, "Hey, I would like to contribute. I would like to be part of the project, but I'm not technical." For instance, they say, right? So there are multiple ways so they can contribute. Like as I said, for instance, blogs, and also checking the issues the part of creating content. I think that is
Mhm.
great. It's also very very needed, but it's great to know that it's an open source project. It's one of the great open source project I've seen to. I mean, I love the part of the visual. I mean, the visual of AutoGPT, I think that it's great to understand and to
Yeah,
check it, because RAG is being complicated, right? So there are multiple bars and everything.
yeah. I think the cool thing with this kind of thing is you could envision yourself, right? Like anybody can drag and
Mm-hmm.
drop, build a RAG pipeline, and then directly integrate it into your WordPress website, your Vercel website, whatever, or your existing systems. And you don't need to feel like it's a whole bunch of a programming task. It's literally just drag and drop and pull your data into the right
Yeah, and it
places.
has 167K stars, so it's a famous project,
Yes.
right?
Yes. Very, very popular. Yes.
No, that's great. I mean, I love it. I love it. I think that was great, very educational for both people that is not 100% familiar with RAG, and for those that are familiar with RAG and they would like to use it. I think that is very educational too. Um, so anything else I would like to share, like ways to contact you, ways to contact the project, or anything that you would like to share?
Yeah, feel free on GitHub or Twitter or LinkedIn is fine as well. I will merge this block that we did create later on. So if anyone wants to contribute to actually adding RAG
Mm-hmm.
techniques as well, that's a really cool way as well. There's so many research papers. Read one of them and just write the code for it. That's literally what I did for the hide one, chain of thought.
Amazing.
And the other one that I was going to do was going to be multi-query. But if anyone has any other ones, that'll be really useful for
No,
us
that's
as well.
amazing. That's amazing. All right, all right. So yeah, thank you so much. I mean, it was an hour, so we really appreciate you to have you here. It was very great. So thank you so much. Thank you for your time you spent on that. So thank you. We really appreciate it.
Thank
And for the audience, so thank you so much for your time. We'll be doing a next coding session in the next month. We'll be around explainable AI and something like that. But I hope to see you all in the next month. Thank you so much, Aarushi, and thank you so much, everyone.